Uh, Good morning or afternoon, everybody. Today you're going to go over section 4.3, which will be the rules of logarithms. We're going to go over there's three main rules, product rule, quotient rule, and power rule. And we'll go over those, and we'll also talk about how to change the base of a logarithm. Step 3 here says apply logarithms in growth and decay. We'll get to that tomorrow. So the main two things here, learn the rules and apply the rules of logarithms, and then change a base of a logarithm. All right, you should have some guided notes that were passed out to you. And this first part is not on the guided notes. I'm actually just going to go through the rules and how they're applied, and then we're going to kind of build them up and put them in some more complex situations. So log of 5 plus log of 6 can be written as a single log. And that single log is log of 30. Okay, so sometimes the rules of logs do not appear to be what we first think they will be, because when you see the plus, a lot of times your mind's going to say 5 plus 6 is 11. You actually multiply. So log of 5 plus log of 6 is equivalent to the log of 30. Now remember, that's base 10. So if I just put this up here, log of 5 plus log of 6, that'll equal that decimal. That will be equivalent to the log of 30. Okay, so you actually multiply. Well, for the second one here, log of 20 minus log of 5, what do you think that will be? That is going to be the log of 4. You divide. So if I take log of 20 minus log of 5, I'll get a decimal. That is equivalent to log of 4. And then the third one that we deal with is one deals with the powers. And so the log of 2 to the third power is equal to 3 times the log of 2. So anytime you got a power, that can move out in front is a multiplier. So if you have the log of x squared, that will be the same as 2 times the log of x. This will be a very important property in helping to solve equations. So if I go to my calculator, log of 2 to the third power, I get that, and then that should be the same as 3 times the log of 2. Okay, so there will be equivalent. All right, now this should be on your guided notes here. The product property. Now this is good for any base. We just talked about base 10 for those first ones just because it's a little bit easier to write, but this could be any base A there. So log, and actually you can go from left to right or right to left. But if you have the log of two things being multiplied, you can write them as the log of the sum, log of base A of m plus log base A of n, and vice versa. All right, we are going, so if you got, log base 3 of 7x, we can write that as the log base 3 of 7 plus the log base 3 of x. Okay, so that can be split up. And if I have the natural log of 8 plus the natural log of 4, I can write that as a natural log of 32. Natural log falls under the same rules. This is one you will have to prove. Okay, you will have, and we're just going to prove it in base 10. So that means log of m times n equals the log of m plus the log of n. This will be on your test. I'll tell you that now. Okay, so that is your proof. In a proof, this statement right here has to be the last statement of your proof, and you cannot use it anywhere within the proof. Here's how we're going to start. Here is your first step. Okay, you want to let x equal log of m and y equal log of n. Now, we're not going to do the old 2-column geometry proof. We're just going to go through our steps, have to be mathematically correct and justified, but we're not going to do a statement and a reason. I'll kind of explain what's going on and make some notes, which you can use if needed. The second step is we want to take these statements and convert them to log form. Remember, this is exponential form. So this is base 10. So you would say 10 to the x equals m, and 10 to the y equals n. Third step. Okay. Now, I'm going to take the m and the n, and I'm going to multiply them together, because if you look up here, I have m times n. Well, using what I know, since m is 10 to the x and n is 10 to the y, m times n has to equal 10 to the x times 10 to the y. Step 4, I can use my exponent rules over here. Anytime I got the same bases and we have powers and it's multiplied, we can actually add the powers together. So that's 10 to the x plus y. Now the next step here, what you want to do is we want to convert this statement right there to log form. So if I convert that to log form, it'll be the log base 10, which I don't write, of mn equals x plus y. Remember, the answer to a log is always an exponent. So the log base 10, or just the log of m times n, equals x plus y. Well, my last statement has to be this statement up here. And I'm almost there. All I have to do is take the x and replace it with log of m right there, and the y and replace it with log of n. So for step 6, and the final step, the log of m times n equals the log of m plus the log of n. Okay, and there's your proof. You have to have all 6 steps when we do this for the test. I'll tell you that now. Cannot skip a step, and there should be no need to add a step. So you need to do those 6 steps. So that is the proof of the product property. Okay, that's the first one. Second one, quotient property. We're not going to prove the second and third one. Quotient property. Log base A of a ratio or a fraction can be written as the log base A of m minus the log base A of n, or vice versa. So if I have the log base 3 of 7 over x, that equals the log base 3 of 7 minus the log base 3 of x. And then in the original, you can go the same or backwards, and if you have a subtraction, you can write as a division. So I have the log base 2 of 14 minus the log base 2 of 2. I can write it as the log base 2 of 7, because I can take 14 divided by 2. Power property. Third one. Log base A of any constant to a power can be written as that power times log base A of m. So if I have log base 3 of 4 to the 8th power, I can make that 8 times log base 3 of 4. And if I have the natural log of 7 to the x power, I can write that as x times natural log of 7. So I got that. So those are our 3 properties: power, quotient, and power, or product, quotient, and power. You got to be able to prove that first one there. Okay, some applications here, or some problems dealing with these properties. Okay, given the fact, and I'm just going to state this, that the log base 5 of z is equivalent to 3, and the log base 5 equals 2. We want to evaluate each expression. So right now we can't evaluate it, but we want to use our properties. Since this is a product, I can split it up and write it as log base 5 of y plus log base 5 of z. Well, log base 5 of y is equivalent to 2, so take that out or replace it with a 2. Log base 5 of z is equivalent to 3. So that means that the log base 5 of yz is equal to 5. That's all we got to do. All right, second one here, letter B. Log base 5 of 125y to the 7. And we're going to go through a couple problems here, but you got to be really careful where this exponent is and what the exponent is being applied to. It is not being applied to the whole expression. Okay, so you have to go piece by piece. This is going to be a product of two things. The first one's 125, the second one's y to the 7th. Since it's a product, it can be split apart into the log base 5 of 125 plus the log base 5 of y to the 7th. Log base 5 of 125. Now, since I got this exponent, I can write that out in front and write it as 7 times the log base 5 of y. Well, when you're just left with constants, log base 5 of 125, you want to see if that can simplify. That's saying 5 to what power equals 125. That would be the third power. So that answer is a 3. Plus 7 times the log base 5 of y. And what do we say the log base 5 of y is from up above? The log base 5 of y is 2. So that becomes 7 times 2. That becomes 3 plus 14, which equals 17. So that's going to be our answer for the log base 5 of 125y to the 7. Split it apart using the product rule, and then we use the x power rule here, and then we simplify. So the final answer is 17. Okay, two things you're going to see with logs. One is going to say write in condensed form. Next one will be write in expanded form, basically going from one to the other. For condensed form, you want to use your properties to write it as a single log. So in the end, there will just be one log, one base, and then one expression there. Well, if there's a plus, remember we said we can multiply. Log base 4 of 3 times 6 is 18. Now you always want to take a look and see whether it will simplify into a common constant. Log base 4 of 18. Does 4 to what power equals 18? Well, is it a nice number? Is it a whole number? No, it's going to be a decimal. So in that case, you're just going to leave that. That is our answer right there. Log base 4 of 18. Now when it says write it as a single log, there cannot be anything in front of it. So we're going to use the power property in reverse. If there's a constant in front, that can become a power. So this will be log base a of 4 to the third power. Well, log base a of 4 to the third power is a log base a of 64. Since we don't know what the base is, we cannot evaluate that any further. That would be our final answer. All right, take a look at this last one. Okay, so I got a constant out in front, and then I got a minus. So we kind of got to do order of operations. I got to take care of this power. So that becomes log of 36 to the 1/2 minus log of 2. Remember, the 1/2 power is the same as the square root. So 36 to the 1/2 power is the same as the square root of 36, and the square root of 36 is 6. So that becomes log of 6 minus log of 2. Using the quotient property, if you have a subtraction of logs, you divide the expressions. So that becomes log of 6 divided by 2, which is the log of 3. That needs to be the final answer for this case. 1/2 log of 36 minus log of 2. All right, go in the opposite direction. That's going to condensed form. We write it as a single log. Expanded form. We're going to use our properties and write it using sums or differences or powers. Constants in front. Key thing here. Your final answer can have no products, quotients, or powers with what we're taking the log of. So right there, we got a couple of things. I got a power and I have a quotient. I can't have either. Okay, so we got to expand this to get rid of those. All right, we're going to use quotient property first because this 2 is only applied to the a, not the whole thing. So this is going to become the log base 2 of a squared minus the log base 2 of b. Now that's better, but it's not done because I can't have any powers. So this 2 has to go out in front, become 2 log base 2 of a minus log base 2 of b. That will be expanded form. Okay, so you're looking at this right here to make sure it has no products, no quotients, or no powers. So they can see if it can be split up again. Okay, for number 2 here, you got to watch and see where the exponent is. So the exponent is on both the a and the b. So I can make this 4 times log base 3 of AB. Now AB is a product, cannot leave it, so that can be split apart. So now I can make that 4 times the log base 3 of A plus the log base 3 of B. Okay, now if I leave it exactly how I have it written, that's going to be incorrect. This 4 has to apply to everything within this problem. And when you split it apart, you got 2 options. You can put parentheses around the whole thing. That would be correct. Okay, I'd accept that. Or you can just distribute it at the same time, and you can make it 4 log base 3 of A plus 4 log base 3 of B. So you can do that. Okay, I would accept either one. Make sure you read directions. It might say one over the other. Usually not, but every now and then it might. All right, so that's your second one there. And again, watch where that exponent is, because if it was log base 3 of a b to the 4th, then you're going to have a different answer, not the same problem. Okay, look at this third one. Look at this third one. Got a lot going on. We got fractions, we got things being multiplied, we got a power. All right, first thing we're going to do is get rid of the quotient. I'm going to take the log of a times a minus 1 minus log of a plus 2 squared. All right, I had this part here. Still has a product, and this one still has a power. So this product can be split apart into log base a plus log of a minus 1. Minus, this 2 goes out in front. And log of a plus 2. All right, now the log of a minus 1 right here. that is not a power, or it is not a power, it's not a product, it's not a quotient. You cannot simplify that. That is done. Same thing with the last piece. 2 log of a plus 2. Cannot simplify that. That is simplified as far as possible. This is our final answer. Now, these properties allow us to take this next step. Now, your calculators, those of you who have the change of base, this isn't as important because you can use the change of base, but before they put the change of base in there, and even in general, there will be times you need it when your calculator won't work, especially if we're dealing with variables or expressions. But mine does not have the old change of base. So we're going to go over how these properties help us figure out what log base 2 of 7 is. Well, let's think about what this means. This means 2 to what power equals 7. Now, logs allow us to take an exponent and put it out in front of a log. Well, at this point, I don't have any logs. Well, with any equation, as long as you do the same thing to both sides, it remains equivalent. So I'm going to take the log base 10 of both sides. Now, I just say base 10 so I don't have to write a base in there. You could technically take any base, but it's going to be easier if you just do base 10. So I got log of 2 to the x equals log of 7. When you do that, when you take the log of both sides, now when you look at the log of 2 to the x is an exponent, that can go out in front as a constant. And I can now solve for x by dividing by log of 2. Log of 2 will be a constant, not a nice one. It'll be a decimal, but it is still a constant. And so I'm going to, for now, x equals log of 7 over log of 2. And we can go to our calculator and we can do log of 7 divided by log of 2. And we get this answer. That's my decimal. And if I take 2 to that power, what should I get? 2 to that answer better be 7. Now, depending upon the scenario, depends on what you round it off to. Let's go. In this case, a lot of times it is 3 decimal places. Let's do that. It'll be 2.807. That would be the answer there. This leads us to this change of base formula you see in your guided notes. For a not equal to 1, base not equal to 1, and m is a positive real number. Okay, log base a of m is equivalent to the log of m divided by the log of a. Okay, and you see what happened here with log base 2 of 7. When we did this work, we ended up with the log of 7, okay, which you see right here. Log of 7 divided by log of 2. So that's our change of base formula. Now it can be we can make this any base right here, whatever we want to make it. Typically, it's easier if you do it base 10 or base E, but it technically doesn't matter. And there might be some situations where that comes up. Now, this is how we go about this. Compute log base 5 of 13 by using common logs and then natural logs. Common logs are base 10. So I got log base 5 of 13. All you do is take log of 13 divided by log of 5. And that's going to give me 5 to what power equals 13. And so I got, I'm going to clear this out. I got log of 13 divided by log of 5. And I get 1.5 for that. I said it didn't matter what base. Those two are just the easiest because they're on your calculator in a convenient spot. So I can say, all right, the log base 5 of 13. If I use natural logs, take the natural log of 13 divided by the natural log of 5. So ln of 13, divided by ln of 5 will give us the same answer. And I get 1.594 for that. Now, with those of you who have the new, which is the vast majority of you, where you just hit math and then you go to the log base, it will spit it out. There will be certain situations where you need to know this case anyway. Okay, so don't assume because you have that you can just ignore this. You still need this.